Okay, guys, this is the last video. I know it's so much info. Okay, but anyway. So I'm going to go through the example with you on page 140 of your textbook. Open there and go through it with me. Make sure you understand. Okay, so they'll ask, simplify the following as far as possible. Then they'll give you cos of 180 plus theta and cos of 180 minus theta. And you have to divide the two. Okay, so now, because I told you in the previous video, if you see this, guys, you need to recognize it as a reduction value or reduction formula. Okay, first of all, you need to figure out in which quadrant this will fall. That's why you need to know this, okay, which was in the previous video, the little summary. Okay, the top one falls in the third quadrant. Okay, 180 degrees plus theta is in the third quadrant. Okay, and cos is negative in the third quadrant. So here, how you're going to work it out is this is the same as negative cos theta. Remember now, when I showed you the examples and everything we did in the previous videos, if I calculate cos theta and I calculate cos 180 degrees plus theta, we will have exactly the same answer, only the signs will differ. So this one is negative cos theta divided by this angle falls in the second quadrant, and cos is also negative in that quadrant. So it will be the same, negative cos theta. So this is interesting. I see this one and this one will have exactly the same answer. Okay? And if this one divided by that one equals 1. Okay. So let's do the second example, second and third one. Okay. Here we have a little bit longer one, tan times sin of 360 minus theta, okay, divided by that. Okay, first of all, you determine the quadrant in which this angle falls and then the sign of the function value. Okay, so first the quadrant and then you ask yourself, is sin, cos, or tan, or whatever you are working with, negative or positive in that quadrant? Okay, so what they did here, they wrote it down exactly the same. They just wrote the quadrants here which that angle falls in. So this one falls in the third quadrant. 360 minus theta falls in the fourth quadrant. And that one falls in the fourth quadrant. They are the same. Okay. So tan of this angle in the third quadrant is positive, because tan in the third quadrant is always positive. So that will be the same as tan theta, but with a positive sign. This, guys, sin in the fourth quadrant is also negative. Okay, that's why you have to know cost. So this angle is the same as sin theta, but it's negative because in the fourth quadrant, sin is negative. Tan over here, fourth quadrant, tan is negative because cos is positive in the fourth quadrant. The rest are negative. So we have negative tan. Then these two, tan and tan over here, will cancel. And we are left with negative sin over negative 1. And then the two negatives will cancel and you get sin theta. Okay, guys, how cool is that? So we went from that whole thing will be exactly the same answer as sin theta. Okay, then example C. Okay, here the only difference between this and the previous examples are here we have an exponent. Okay, so basically they're just going to explain to us how we deal with an exponent here. Okay, guys, remember here it says as well that when you put an exponent here, it means exactly the same if you put it over here at the outside the bracket at the end. Okay. So it is important to remember that tan to the power of 2 of theta is the same as tan theta to the power of 2. These two mean exactly the same thing. And it's the same for sin and cos. So first of all, we move this exponent to the back. Okay. So it's 1 minus tan 360 minus theta to the power of 2. Okay. Then in which quadrant does this angle fall? Okay, then we know because we wrote this down from the previous video. It falls in the fourth quadrant. Okay, and we know that this angle is the same as tan theta, but it will only be negative because tan in the fourth quadrant is negative. So before we even deal with the exponent, we work that little part out. Okay, so 1 minus stays the same, and now we have negative tan theta. Okay, now why did that suddenly change to a positive sign? Because negative tan theta times negative tan theta, that is the exponent, guys, is positive. 2 negatives equal a positive. Okay, and a negative times a positive is a negative. So that will be your final answer. You cannot simplify it any further than that. Okay, and then they say here, take careful note of the above example which deals with the square of a trigonometric function. The square meaning that. Okay.